Subscribe my channel by pressing red button.
Today I am going to discuss about Doppler's effect, which is the chapter of sound or wave motion. In Doppler effect, the definition is the apparent change in frequency of sound observed by the observer when there is a relative motion between the source and observer is called Doppler's effect. Here we have to consider two objects, that is, one is source, another one is observer. This is source, that means the source of sound, and this is observer. Here the source of sound emits the sound waves from this. The example for this source of sound is an ambulance or something. Here observer means a human being who observes the sound here. Here we have to find the apparent change. Apparent change means it is not a real change, but this observer feels that the sound is increasing, the sound is decreasing. So in this concept we have to observe when the source is moving towards the observer, what happens. Another thing is the source is moving away from the observer, then the resultant will be, if the observer is moving towards the source and the observer is moving away from the source. Here we have to find out the four cases. Generally, if source is moving towards observer, then he receives more waves, that means the sound will be increased. If the source is moving away from the observer, he feels that the sound is decreasing. Similarly, observer also moving towards the sound, then he hears high sound, and observer is moving away from the source, he hears the less sound. For this we have to take one equation, that is V is equal to n lambda. V is equal to n lambda. Here V is equal to velocity of sound in A. N is equal to frequency. Lambda is equal to wavelength. So I have to remember this notation, V is equal to n lambda. Here two more parameters are added. Those are, let Vs is equal to velocity of source and VO is equal to velocity of observer. Velocity of observer. So here you have to find n dash and lambda dash. That means n dash means apparent frequency and lambda dash means apparent wave length. Here we have to remember a thing which was not prescribed in any textbook or any videos, that whenever the source is here, observer is here, any one of these two objects are moving towards left is taken as positive. That means if the source is moving towards left side, that means the Vs is taken as positive. If the source is moving in the right hand side direction, then Vs is taken as negative. This is the main key point here. Towards right is taken as negative. Remember, if the observer is moving, left hand side is taken as positive. That means VO, and right hand side is taken as negative. That is VO is equal to minus. Here towards left side it is taken as plus Vs. If this source is moving towards right side, this is taken as Vs, which is negative, and the observer moves along left side, it is taken as plus VO, and this is taken as minus VO. We should not forget this thing. Okay, now I have to check the case study. First one is case 1. Case 1. When the observer at rest and source is moving towards the observer. We know very well, when observer is at rest, the source is moving towards the observer. Here, the source releases the waves like this. Like this. If the source came here, then 1, 2, 3, 4. These 4 waves are compressed into small waves here. Like this. If the source came here, the waves observed by the observer are very compressed. Then what happens? The wavelength changes. The wavelength changes. Here we know the wavelength lambda is equal to V lambda, then here lambda is equal to V by N. Lambda is equal to V by N. Then if the apparent wavelength, the apparent wavelength lambda is equal to, here V is common. V is common here because V means the velocity of sound in air, and the source is moving towards the observer means it is moving in the right hand side. So I have to put minus Vs here and divided by N. Here the apparent wavelength, this gives lambda dash. Lambda dash. Then the apparent frequency, N dash is equal to, if I take an N here, that means V by lambda dash. That means from this equation, this is V by lambda dash. We know very well the lambda dash value is, then the apparent frequency N dash is equal to V whole divided by V minus Vs by N, that is equal to N into V, the velocity of sound in air, by V minus Vs. Here the expression is N dash is equal to N into V by V minus Vs. Here we have to remember this notation. If I want lambda, lambda is taken as V by N. If I want N, N should be considered as V by lambda. This notation here, I'm also writing N is equal to, from this equation, V by lambda. If I take in the apparent wavelength, this should be lambda and this will be V plus or minus Vs or V naught. Okay, this is the first case when the source is moving towards the observer. Now case 2, when the observer is at rest, the source is moving away from the observer. Here at stationary position, the original position is this. Now this source moves towards the left side, that means away from the observer. Then what happens? The wavelength increases here. The notation is same here. The apparent wavelength, lambda dash is equal to this. We have to consider V. Here the source is moving left side, means this is taken as plus Vs by N. Up to this time there is no change of frequency. Now we have to substitute this equation here. Then the apparent frequency N dash is equal to, here this is N dash is equal to V, the velocity of sound in air, which is as it is, no change, and this will be lambda dash. This is equation B. I have to make this equation by using this equation. Then N dash is equal to V whole divided by V plus S by N. V plus S by N. Then N dash is equal to N into V by V plus S. This is the condition for source is moving away from the observer. Here V plus Vs means here the denominator value increases, then the frequency, the apparent frequency decreases here. In case 3, when the source is at rest, the observer is moving towards the source. Here the source is at rest in the same position, but the observer is moving towards the source. Means what happens? There is no change of apparent wavelength. That means the wavelength will be as it is, but the observer receives more waves. That means here from this place to this place, he came here. At this particular place, he was receiving 4 waves, but here he observed, but here there are 3 waves. That means he already received one more wave, that means which is nearer to the source. Then what happens? Here there is no change of any wavelength. The wavelength is as it is, but he was receiving more waves. For that, the apparent frequency N is equal to, the apparent frequency N dash is equal to N plus N, because he was receiving more waves. This is taken as V means here the velocity of sound in air, But due to motion of observer, this V will be converted into V naught by lambda. That means he receives more waves. N dash is equal to n plus V naught by lambda. Here there is no change in wavelength. So we have to express this wavelength in terms of velocity of sound and frequency. Now replace this lambda with this V by n. Then n dash is equal to n plus V naught divided by lambda by n means V by n. That is equal to n plus n into V naught by V. That means n dash. Now n dash is equal to Vn plus n V naught divided by V. Then n dash is equal to, if I take n as common factor, then V plus V naught by V. Here the n dash is greater than n. N dash is greater than n because the observer is moving towards the sound. Then he experiences high sound. Case 4. When the source is at rest, observer is moving away from the source. So the source is same position, but the displacement of observer is towards right hand side, which is opposite to the source. So what happens? He was missing certain waves. He was getting 4 waves here constantly. When he moves away from the source, that means the sound will be decreasing. So then the apparent frequency n dash is equal to n. That means he was missing some waves. That is n minus V naught by lambda here. N minus n. That means he was missing some waves. That means V by lambda. V means velocity of sound in air, but here V naught means observer. This minus is because of the right hand side motion of the observer. Here also there is no change in wavelength. The wavelength is same here and here. Now replace wavelength in terms of velocity of sound in air and frequency. That means n dash is equal to n minus V naught by whole divided by V by n. Then n dash is equal to n minus n V naught by V. Then n dash is equal to nv minus n V naught by V. N dash is equal to n taken as common factor V minus V naught by V. This is the condition for the observer moving away from the source. That is minus V naught. If the observer moves towards the source, that is left hand side, that will be V plus V naught. So then n dash is less than n. The actual frequency is n. The apparent frequency is n dash. So n dash is less than n. Finally, the synopsis of this question is, when the observer is at rest, the source is moving towards the observer is taken as the apparent frequency n dash is equal to n into V by V minus Vs. Here Vs means the source. When the source is moving towards the observer, which is taken as negative here, right hand side is taken as negative. For the second equation, the source is moving away from the observer, that is n dash is equal to n into V by V plus Vs. That means when the source is moving in the left hand side, that is taken as positive term. Now the source is at rest, the observer is moving towards the source is taken as n dash is equal to n into V plus V naught by V, and the observer is moving away from the source, n dash is equal to n into V minus V naught by V. Here plus V naught means the observer is moving towards the source, which is left hand side. Here I consider plus V naught, and the observer is moving away from the source, which is minus. The applications of this Doppler effect is to determine the velocity of the aeroplanes and the positions of the submarines in the sea, and the positions of the icebergs in the sea. But nowadays they are finding the velocities of vehicles in the traffic signals. Okay, the velocity of the vehicle can be determined by using these techniques. Here they are determining the velocity of the car or velocity of the bike. Then it is used to determine the Saturn rings and twin stars in the galaxy. Okay, you prepare well. This is an essay question. This is very important question, and like my channel and subscribe my channel. Thank you.